After we've detected autocorrelation, we need to know how to deal with it. And we need to consider two cases when we know the autoregressive coefficient, when rho is known. In this case, we will just apply the method of generalized least squares. However, we almost never know the true rho coefficient. It's never known, therefore we have to use some other methods which are summarized over here. Let's go through those methods one by one. And let's start with the more optimistic case when we know the coefficient of autocorrelation. So in this case, we just use the method of generalized squares. So let's consider the following regression model where y is just a function of x, and assume that the error term follows the first autoregressive scheme, the one that we've seen before. And now instead of having equation in the current period, let's rewrite it into the previous period. Let's rewrite it for the previous period, t minus 1. So we get the following equation. Yt minus 1 is equal to beta 1 plus beta 2 xt minus 1 plus ut minus 1. After we've done this, we take this equation and we multiply both sides by the coefficient of autoregression, so by the rho coefficient, and we get the following expression. In the next step, we take equation 23 and then we take the last equation and we subtract the last equation from the original equation. When we do this, we get the following function, which can also be expressed in the following ways. So b1 star, this is just beta 1 star, this is just beta 1 y minus rho. T with the star, this is just yt minus rho yt minus 1. Xt with the star, this is just xt minus rho xt minus 1. And beta 2 with the star is just the original beta 2. So the obtained estimates of beta 1 and beta 2 are known as generalized least squares estimators. However, as I told you, we almost never know the true rho coefficient, the true autoregressive coefficient, therefore we have to use some alternative methods. And this is the method I actually mentioned in somewhere in the introduction when I discussed the sources of autocorrelation is the first differences. So if the U term is found to be autocorrelated, what we can do is we can apply the first differences, right? So we take we take the function in period t, and we take the function in period t minus 1, and we subtract the function for the previous period from the function for the current period. And we get the following expression. It is recommended to use the first difference transformation when the estimated Darwin-Watson statistic is lower than the r squared from the original equation, so from the equation in the level form. Instead of using first differences, we can also use another method. We can calculate the rho coefficient based on Darwin-Watson statistic. And here is the formula how it's done. So it's just 1 minus Darwin-Watson statistic over 2. After we get the rho coefficient, we just employ the method of generalized least squares, right? So we use this method. So, but instead of having the true population rho, we will have the estimated rho coefficient. We can also get the rho coefficient from the residuals, right? So we take the estimated residuals and we regress the residual current period on its own value from the previous period, and again get the estimated rho coefficient. After we have it, we can employ the method of generalized least squares. The only problem is that this is just an estimated autoregressive coefficient. This is not the true autoregressive coefficient. Therefore, our results might not be that perfect.